So hi there, this is Ayush, and in this video we will test and finalize our selected ball screw parameters that we have calculated in the first part of this ball screw selection video. And the tests are critical speed test, buckling load test over the ball screw, and expected life test of the ball screw. And there can be more tests like a stiffness test, thermal expansion test. And before doing any test, first we need to know these three parameters as per the given condition. First, maximum axial load on the ball screw. Second, maximum RPM of the ball screw, revolution per minute. And third, we have to choose a suitable bearing support arrangement as per the given condition. And after that, we will start critical testing on our ball screw with respect to these three parameters. So let's start with calculating maximum axial load on the ball screw as per the given condition. And the given axial load on the ball screw is 50 kg. Plus we should consider sliding plate weight force where we will mount this drilling system. So let's say the plate size is 5 kg. So the net force will become 50 plus 5 equal to 55 kg. 55 kilogram force. And now convert the kgf to the Newton. So multiply with gravity of acceleration 9.8 or 10. So the load will become 550 Newton. And this is a static load, not dynamic load. और यहीं पे most of designers mistake कर देते हैं dynamics load को ignore करके. And here we can divide the dynamic loading condition into three stages. 1. The uniform motion. 2. The motion with the acceleration at the starting of ball screw movement. And third, deceleration at the end of the stroke. क्योंकि ball screw एकदम से start और stop नहीं होगी. There will be some slope in motion, something like this. Also, motion can be down to up and up to down. So let's first calculate the load during upward uniform motion against gravity. So force will become weight force, which is 550 Newton, plus sliding friction force of the ball screw itself and the guide. And because the application is vertical, sliding force will not much. You can calculate it, but here I am considering it 20 Newton. So the net axial force during the uniform motion is equal to 570 Newton. And now let's calculate the force on ball screw during the upward acceleration. And this will be the maximum force on the ball screw because this acceleration motion is against gravity. So the force will become force during uniform motion plus inertia force due to the acceleration. So max force will become 550 Newton plus total mass multiplied by the acceleration. But the acceleration is not given in our requirement data. Acceleration time is given. So acceleration will become final velocity, which is 0.4 meter per second minus initial velocity 0 divided by time taken 0.2 second. So the acceleration will become 2 meter per second square. And now put this value in the equation. So maximum force will become 680 Newton. And force during rest of condition like downward acceleration or downward uniform motion will be definitely less than the maximum value because in the downward condition gravity will help in the motion. So we have calculated the maximum load on ball screw is 680 Newton or we can say 68 kilogram force. And now let's calculate the maximum RPM of the ball screw. And we can simply calculate it using the formula. So Nmax will be equal to Vmax linear velocity into 60 into 10 to the power 3 divided by the lead and put the values. So Nmax will become 2400 RPM. And now it's time to choose the bearing arrangement for the ball screw. So in the case of ball screw, load direction is axial and motion is radial. Means there is a thrust load as well as radial load. So we have two options. If the load is moderate, we can go with the angular contact bearing arrangement, or if the load is heavy, we can go with the taper roller bearings. So here the load is moderate, so we can go with the angular contact bearing. But we don't need to design the bearing blocks. The tons of manufacturers are already selling bearing block for the ball screws, and their bearing blocks comes in generally two categories. First, the fixed type of bearing block, and second, the support type, or we can call it float type bearing blocks. In the fixed type bearing block, there are two angular contact bearing in back-to-back arrangement. If you are designing a system which is subjected to vibration, the numbers of bearing can be more than 2 to minimize the vibration. And at the one end, there is a lock nut and there is two washer at the both sides. So we can put the screw in something like this. At one end, a screw step will be there, and at other side we can make the thread on a screw after the machining and fix it with the nut. So ball screw will fixed with the bearing block. So ball screw will not slip within bearing blocks. And this is why we call it fixed bearing block. And we fixed the fixed bearing block at the top towards motor side, so it can also support the ball screw hanging. And at the bottom side or other side, we generally use support bearing or float bearing. And in the support bearing, there is a radial bearing which is free to slide within the bearing block. So if there will be a manufacturing tolerance in length of a screw, support bearing location can be easily adjust itself. And this bearing only support radial load. All the thrust load will be supported by fixed bearing only. If the thrust load is high and you are designing for a vibration condition, then you can use fixed bearing block at the both side. And their bearing support factor will be maximum, which is 1. And for the fixed float bearing arrangement, bearing support factor will be 0.6. But when you will use fixed bearing block at the both side, then you have to precise machining the ball screw. Otherwise, fixed bearing arrangement will apply excessive compression load on the ball screw. So always try to avoid fixed bearing. So always try to avoid fixed bearing block arrangement, and in general use the fixed float bearing arrangement. So now we have made the selection of bearing block arrangement, the fixed float bearing arrangement. If you want to know how to make the correct bearing selection for different application and different loading condition, and how to calculate their service life, please let me know in the comment. I can make a complete guide series on this topic. By the way, I am certified engineer from SKF on the bearing selection. And now we have to make the selection of bearing block size. The fixed float or float fix is the arrangement type. And our calculated ball screw size is 32 mm diameter. Because this is a screw, we have to check the root diameter. And rolled ball screw size 32 mm diameter with the lead 10 mm. The root diameter given in the catalog is 26.91 and closest available bearing block size would be 25 mm. So let's consider bearing block size is 25 mm. And here I have already downloaded the fixed bearing block and float bearing block of size 25 mm. And there is two design of fixed bearing block. One is the foot mounting and one is the flange mounting. And let's see which one we will use and why. So now let's check the critical speed test of the selected ball screw with the fixed float bearing arrangement. But what is critical speed? We can say critical speed of a shaft is the speed or range of a speed where rotational speed of the shaft match with the first natural frequency of that shaft. And when the natural frequency will be matched with the rotational speed, there will be a resonance. And due to the resonance, ball screw can vibrate excessively and it can be bent. So we must know the first natural frequency of the selected ball screw with selected bearing arrangement. And our selected ball screw should not run closer to the critical speed. Otherwise resonance can be occur. But if you are a fresher or a student and you don't know what is the resonance, what is the natural frequency, what is the mode shapes, I will leave some YouTube video link in the description. And to find the natural frequency of the ball screw, we can use this formula. Critical speed equal to
2.71
multiply by 10 to the power 8 multiply by mf, the bearing factor. And here we can consider bearing factor 0.689 for the fixed float bearing arrangement, and multiply with dr, root diameter of the ball screw, and divided by lt, the distance between bearing blocks, and we have all the values. So if you will calculate the critical speed, it will become
4,023
rpm. So the maximum permissible speed at which resonance will not occur, we can use this formula. Np is equal to 0.8 multiplied by the critical speed, and this will become
3,218
rpm. And our calculated maximum speed of the ball screw is 2400 rpm, which is much lower than permissible speed, means our selection is okay. Also we can check with the manufacturer technical datasheet, and here this is fixed float bearing arrangement line. In x-axis, length of a spindle is given, length of a screw, and don't worry about this table, you will find it in every manufacturer catalog. I will leave this in the description. And here this is not 3 mm. A scale is 10 to the power 2, means this is 300 mm, then 400 mm, this is 500 mm, and from here a scale is 10 to the power 3, means 1 meter. So our ball screw length 1300 mm will be something around here, and our ball screw diameter line is this 32 mm diameter. And if you will match this, the critical speed would be around
approximate 3, so it will become 3 into 10 to the power 3, 3000 rpm.
So the selected ball screw critical speed should be under this value, and our ball screw is safe. Top of that, you can also check the critical axial loading, and I'm leaving this up to you because there is no any heavy load. And now we can check the buckling load. But what is the buckling? We can say when ball screw or anything goes under certain compression load, there can be a visible deflection, and this thing called buckling. And in our case, load is not much, but we can calculate the buckling load with this formula, and we have all the inputs for this formula, or we can refer this table. Check the permissible load for the selected length and the ball screw diameter, and also I am leaving this up to you, and you are master in the calculation. Here I am only showing you how to go through these process, because your requirement can be different, but these method and steps will be same applicable for your requirement. And you can also go for the stiffness check, thermal expansion test as per your requirement. And if your selected ball screw pass all these checks, then we can go for expected service life calculation. And here service life is given in number of revolution, and the formula is cubic root of dynamic rating load divided by axial force into 10 to the power 6. So the dynamic load rating we have to check with the catalog, manufacturer catalog. And for the rolled ball screw, diameter 32 with the lead 10,
3252.
And the maximum axial load we have already calculated, 68 kgf. So the service life will become
109376 multiplied by 10 to the power 6 revolution.
And to convert the number of revolution, to the hours, we can use this formula. And if you will put the values, the numbers of hour will be become
759560 hours.
If I did the right mathematical calculation, I am not good in mathematics. And this number is much more higher than our expected life of the ball screw, which is 20,000. So congratulations, we have completed the ball screw selection procedure, and also we have select the bearing block arrangement. And here I have already downloaded the CAD model of ball screw nut. You can also download this CAD model from the video description. And in the next part of the series, we will calculate how much torque will be required to drive this linear actuator. And according to the calculated torque and already calculated speed, we will make the selection of motor. And the next part is on your screen, or you can check the description. Next part will be not as much longer. And thank you very much for the watching.